In this lecture, we are going to learn about the sorting algorithms. Now, there are several sorting algorithms available that can be used to sort a list of elements. Some commonly used sorting algorithms are bubble sort and selection sort and the insertion sort. So let us start with the bubble sort algorithm. Bubble sort repeatedly compares adjacent elements and swaps them if they are in the wrong order. The largest element bubbles to the end of the list in each iteration. The function bubble sort takes an array as input. The variable n is assigned the length of the array using the len function. The outer loop for I in range n-1 iterates through the array from the first element to the second to the last element. This loop controls the number of passes through the array. The inner loop for j in range n-1 iterates through the array from the first element to the second to the last element in each pass. This loop compares adjacent elements and swaps them if they are in the wrong order. Inside the inner loop, the if statement checks if the current element arrj is greater than the next element arrj plus 1. If the condition is true, a swap is performed using a technique called tuple unpacking. arrj, arrj plus 1 is equal to arrj plus 1, arrj. This swaps the values of arrj and arrj plus 1. After the inner loop completes for each pass, the largest element in the remaining unsorted portion of the array bubbles to its correct position at the end. This process continues until the outer loop completes all the passes, resulting in a sorted array. So basically, the bubble sort is a simple sorting algorithm that repeatedly compares adjacent elements and swaps them if they are in the wrong order. While it is easy to understand bubble sort, it is not efficient for large arrays and has a time complexity of O(n to the power 2). It is commonly used for educational purposes rather than in the production code. Now let's move on to the selection sort algorithm. Selection sort finds the minimum element from the unsorted part of the list and places it at the beginning. It repeatedly selects the smallest element and swaps it with the current position. Now let's try to understand how selection sort works in a step-by-step manner using this Python code. Selection sort function takes an input array arr as a parameter. The variable n is assigned the length of the input array using the len function. The outer loop for I in range n-1 runs from the first element to the second to the last element of the array. This loop is responsible for selecting the minimum element in each iteration. Inside the outer loop, the variable min_idx is initialized with the current index I. The inner loop for j in range I plus 1, n runs from the next element after I to the last element of the array. This loop is used to compare the elements and find the minimum element in the unsorted portion of the array. Within the inner loop, an if condition, if rrj less than arr min_idx checks if the current element arrj is smaller than the current minimum element arr min_idx. If it is, then min_idx is updated to the index of the new minimum element. After the inner loop finishes, the minimum element in the unsorted portion is found. The elements at index I and min idx are swapped using a simultaneous assignment statement. Here it is on your screen. This places the minimum element in its correct position in the sorted portion of the array. The outer loop repeats this process until the second to last element, ensuring that the entire array is sorted in the ascending order. So this is how the selection sort algorithm sorts the input array. Each iteration finds the minimum element and moves it to its correct position in the sorted portion of the array until the entire array is sorted. Finally, let's talk about the insertion sort algorithm. Insertion sort builds the sorted list one element at a time. It iterates through the unsorted part and it inserts each element into its correct position in the sorted part. Let's try to understand the working of the insertion sort algorithm in Python. The insertion sort function takes an array ARR as a parameter. The length of the array ARR is stored in the variable n. The outer for loop iterates from the second element of the array, that is index 1, to the last element, that is index n-1. Inside the loop, the current element at index I is stored in the variable key. This element will be compared and inserted into its correct position in the already sorted portion of the array. The variable j is set to I-1, representing the index of the last element in the sorted portion of the array. The inner while loop continues until j is greater than or equal to 0, and the element at ARRJ is greater than the key. Inside the while loop, each element greater than the key is shifted one position to the right to make space for the key to be inserted at the correct position. After the while loop ends, the key is placed at index j+1 to complete the insertion process. The outer for loop continues until all elements have been iterated, and the array is sorted in an ascending order. So this is how the insertion sort algorithm works to sort an array in ascending order. Each element is compared and inserted into its proper position within the already sorted portion of the array. So hope you got the working of the sorting algorithms, bubble sort, selection sort, and the insertion sort algorithms. The proper understanding and working of these algorithms is very, very important and crucial so that you can choose the right algorithms for the right scenarios and situations.